Early peoples were the first to discover the regularities of the moon's monthly trip around the sky. To learn the phases of the moon, understand the nightly habits of Earth's near neighbor, as well as just enough lunar history and physics to say something of interest as the moon sails up over the fence, all this is not too hard to learn. The moon is Earth's only natural satellite. It moves around us from start to finish in just under 1 month. Going outside to look at the moon is a pleasant diversion. The sight of the moon scudding through clouds, painted lightly by the moon's diffuse light, never fails to suggest wonder. Let's suppose it is evening, an hour or so after sundown. The moon is in the south, and it is a half-moon. The half-moon, whatever the month of the year, has certain constraints on how it looks and where it goes. The first thing to note is that the half of the moon that is lit up. The westerly side is brightly illuminated. Why? Since the moon shines by reflected sunlight, it always faces the sun's hemisphere, the place it receives its light from. Select the center of the moon's disk. Now draw a line in your mind from this center out to the westerly horizon. The line is slightly curved since it follows the contours of a globe, the celestial sphere, on which the sky objects appear to rest. The end of the line cuts the horizon just where the sun recently set. This line, which you have imagined, is nothing less than a cross-section of the entire solar system, from the Sun and Mercury out to lonely Pluto. It is amazing that such a vast structure is discovered with so little effort. The solar system is right before you, drawn out from your front step or backyard lawn. It is true. Since the moon is within the solar system, it follows the path that you have marked out. A few days before, the moon would have sat on this line about halfway between its current location and the sun. It would, however, have looked much different. It would appear as a narrow crescent. Here is the first principle of the moon watcher. The closer the moon is to the sun, the smaller it appears. Narrow crescents are always close by the sun and never far away. The larger moon flies from the sun, and the full moon is on the opposite side of the sky from the sun. As it gets later in the evening, the half-moon moves towards the western horizon. Since the sky is apparently in motion towards the west, the half-moon that first attracted our attention will move with the sky and set some 6 hours after the sun. Why 6 hours? The half-moon is 1/2 of the way across the sky from the sun. Its location in the sky is 90 degrees roughly from the sun. Since the whole sky turns in about 24 hours, it takes 6 hours to turn through 1/4 of a circle. These figures are rough, since the seasons add complications to these numbers, but it is a fair enough guide. 6 hours is good enough. Now, when and where will a full moon appear? Remember the line in the sky. Just extend it towards the east. It now forms a chord from east to west with its high point at the place where the half-moon sits at sundown. 1 week after the half-moon, the full moon will sit on the eastern extremity of the line. The full moon rises in the east when the sun goes down in the west. The one rises as the other sets. Myth and folklore around the world often tell of an argument between the sun and the moon. The moon went to the far side of the sky to cool off or pout. Since the full moon rises as the sun sets, it moves across the sky all night long, and therefore enjoys the longest tenure in the sky of any of the moon's phases. Each day the moon appears to move towards the east as it sails around the sky. It will appear tomorrow night about 50 minutes later than tonight. When out at night, you will notice the moon is very bright. This is curious, since the light of the full moon is less than the sun's luminance by a factor of about 500,000 at least. Put it another way, if the whole sky were covered from zenith to horizon in every direction with copies of the full moon, until the whole sky was covered, that's 160,000 moon copies, there would still be less light reaching the ground than the light of one sun. The fact that we still see reasonably well under the light of one full moon is a testament to the remarkable nature of the eye. We are able to compensate for a radical reduction in light level in order to continue seeing objects around us. The half-moon, in contrast, is only 11% as bright as the full moon. This, at first glance, seems odd. If the half-moon shows 50% of the area of the full moon, why does it not shine with 50% as much light? If the moon were a smooth surface like a ping-pong ball, it would obey this rule. But as anyone knows who has looked at the moon's surface, it is wrinkly, bumpy, and irregular. The moon is like a golf ball and not like a ping-pong ball. The two surfaces scatter light in very different ways. The golf ball will reflect far less light when equally lit up compared to a ping-pong ball. It's of interest that the nature of the moon's surface could be derived from a simple measurement of its light even if telescopes were unavailable. We might still suppose the existence of deep chasms, hills, and mountains on the lunar domains on the basis of lunar scattering of light. Modern-day explorers of the solar system often make shrewd guesses about the surface properties of bodies circling the sun when it is not feasible to achieve image clarity upon very remote or very tiny objects. Looking at the moon over several days around full moon reveals the moon is very bright. People who know the moon only from pictures in books really owe themselves a look in a telescope or even a pair of binoculars. The moon is much brighter than any photo, and its surface seems alive with tiny details just at the limits of visibility. At higher powers, the wealth of detail is breathtaking. In small opera glasses, or to a certain extent even with the unaided eye, it is apparent the moon has two different global features. A sort of darker stain, called maria, covers about half the visible surface. The maria, the word means ocean or water, was named in the belief that the Earth might be copied in other astronomical bodies. It seemed reasonable that the dark maria might be water, while the highlands or brighter areas might be the dry land. We know today that the moon is extremely dry. Even its rocks are termed anhydrous, meaning they contain little water within. Unlike the heavy Earth, the moon has a small mass. It cannot retain the flighty water molecule, which would sail away like tiny spaceships and leave the moon's weak gravitational field. It is for this reason also that the moon has little or no atmosphere. The famous man on the moon, or lady, or rabbit, are portraits drawn on this dark landscape, a sort of Rorschach test for cultural motifs. Many of the moon features were laid down 3.9 billion years ago in an event called the Major Impact Period in the solar system. The moon was bombarded by asteroids and meteors, some as large as cities, and the heat of the collisions, like the impacts of giant nuclear weapons, was stored within. And there was little way for the moon to rid itself of this heat. Since the moon has a hardened shell and molten bodies remained within, there was a tension on the surface, and the hot stuff began pressing on the crust, seeking a way out. This chance came about 3.7 billion years ago. The great dam burst, and a flood of stored lunar material came flowing out. After the formation of the maria, the number of hits fell dramatically. Surveying the moon with a powerful telescope reveals there are far fewer craters within the dark area than in the brighter highland areas. The conclusion? Most of the hits were laid down before the 3.7 billion year ago epoch. Since that time, over the whole unimaginably long time, the moon has been quite placid. It is true that here and there within the maria there are some white patches, the telltale sign of the late arrival of a giant rock from space. Even the little opera glass reveals the whitish signatures of hits, now called craters, like Copernicus and Aristarchus, yet statistically they are lunar newcomers.